So in this session, we are going to talk about some important and special topic, and it's about the lifespan of an object. And this topic has nothing to do with the Spring and with frameworks. Actually, it's about the design. So for each class and for each object that we instantiate and initialize off of a class, there is this aspect that the designer should actually determine that how much the lifespan of the object that we are instantiating from this class should be, and when it should be destroyed. So those are the design decisions, and it doesn't have to do anything with the IOC container or Spring or any framework, as I said. But because we are offloading this responsibility of instantiation and initialization to the Spring, so we should again inform the Spring and teach it how to do these stuff, how to determine actually the time, the lifespan of an object, and offload this to the Spring as well, so that it should know how many instances should it make and when it should destroy the instances. So again, outside of Spring, if we want to provide a spectrum for the lifespan of an object, when you need an instance of a class and you get an object from class, actually the designer, the programmer, could design that from this specific class. For example, from this car class, there should be only a single instance throughout the whole application, throughout the life of the application when it runs. So that is the left side of the spectrum, and this pattern actually is named Singleton Pattern, and it is inside that prominent book, the Gang of Four Design Patterns books. And the Singleton Pattern says that there will be a single instance of a class inside the whole application throughout the lifespan of the whole application, and that single instance will be destroyed at the end of the application. So if anyone needs actually an instance, it will get the same instance that everybody else have been accessing. That is the one side of the spectrum. The other side of the spectrum is that when you need an instance, you create a new one with the new keyword, and you destroy it and toss it to the trash when you are done with it. That is the other side. So there should be obviously something in between, that when you instantiate some object and you cache it somewhere, and for example a fixed period of time, you use the same instance, but then you create and instantiate another one. So this is the spectrum. So and this is actually about the design. This is the design issue. It has nothing to do with the Spring. But again, the Spring should be able to provide some capability for us to actually transfer this knowledge to the Spring, and to determine each class and each bean definition's scope. So yeah, I talked about the word scope. So that is the scope of an object. That is something that is defined as the scope of an object inside the Spring. And the scope of an object inside the Spring, or a scope of an bean inside the Spring, could be singleton, or which is the left side of the spectrum. Or we could determine that the scope of a bean that will be created off of some bean definition will be, the Spring uses actually the word prototype for instantiating a new one every time we need an instance. Again, the word prototype is coming from the prominent book of Design Patterns by Gang of Four. And but in that book, the prototype actually is something more than creating a new one. Actually, it is cloning an instance off of another instance and getting all the fields and properties. But here, the Spring just has chosen the word prototype for the scope, for the kind of scope that we assign to a bean definition to determine that it will be instantiated in new object every time somewhere needed one. So we could summarize that scope means actually an umbrella or a fixed context or a fixed duration of time that within it the same key refers to the same instance, and when the scope dies, all the instances within it must die. And in that sense, for example, we could say that every object, every instance is a singleton inside and within its scope, within its own scope. So when the scope is the application scope, which is the global scope that spans through the whole application, that umbrella, the object that is singleton means that it will have the lifespan throughout the whole application. There will be only a single instance throughout this whole umbrella, which is the whole application. But when the scope is something narrower, actually, and that umbrella is something actually custom in that spectrum, means that we could have multiple umbrellas with different names, multiple scopes, that within each of them, the same key, which is the bean name, refers to the same instance. And that instance is again a singleton underneath its own scope. So because, as we said before, we are offloading that responsibility of instantiation and initialization to the Spring, we must also be able to determine the scope of the bean definitions. And there is this special annotation named @scope, which is obvious. And that is used to determine the scope of a bean definition. And inside the Spring, there are 6 predefined or built-in or whatever scopes, that 4 of them will be activated when your application become a web application, and when you change your this application context to something that is that they say is web aware application context. But here, because our focus is not the web, we will only briefly talk about them, and we will actually defer them to the later session, to the later chapter about the Spring web applications. So the first and foremost scope in the Spring is the singleton scope. And as you know, throughout these series that we've been talking about the Spring annotation config, we've not seen anything about the scope. And again, if we don't even determine and specify the scope, even if we don't specify it, there must be some aspect of a scope associated with each bean created off of a bean definition. But because we have not specified anything yet, the Spring takes actually specifies the singleton as the default scope of the bean definitions. So if I want to specify it manually, there is this scope inside the Spring, not the one inside the JavaX inject, the one inside the Spring itself. And we could determine the name of the scope as singleton. And this is a string, of course. This is a string literal, and it should be actually correct, and there should not be typos or misspelling. So now, actually, we are specifying it as singleton, but it was singleton before. Now, if I want to prove that it was singleton, here you can see that we are inside the main application. we are creating an instance off of the car class. Now, if we want to create another one, let's say this is car1, and let's say we are going to ask for another object named car2, car instance 1 and car instance 2. Okay, now because the scope of this bean definition is singleton by default, so when we ask an object for an instance from the IOC container, it will check whether it has created or instantiated an instance before and cache it. And if there is any instance, it will return the same one. But if not, it will instantiate it, it will cache it, and it will return it. So if I run it, you'll see that both of them are the same instances. So here you can see that we have not actually overridden the engine to string, and the car is being injected an engine, and the engine is the same one. So you can see that the car is the same car, and no matter how many times we ask for an instance, it will return the same instance and it will return the same object because it's singleton. Now, if we want to change it to something that to the other side, to the other end of the spectrum, that every time we ask an instance off of that bean definition, let's say that we wanted to create a new one. So in that sense, we could come here and override this scope and tell it that we want it to be prototype. So that is the Spring's way of indicating the other side of spectrum. Now, if we run it, you'll see that these two instances actually there must differ, but they are not there is no difference. And let's see why. Actually, it is prototype. It is, yeah, you see these two are the same, and that is because the engine bean definition is singleton by default. So actually I added this constructor here that prints whether it's been called or not, and as you can see, it has been called twice. And if we want to prove that each of them is a different object, we could do something like this. Let's change the toString to something that actually prints the hash code, which is and then the hash code, by default hash code will be the address of the instance. So we could say this dot hash code and something like this. And now if we run it, okay, you can see that the hash codes actually differ, and these are two different instances. Although they have got the same engine, that is because when the first one asks for an instance of an engine, it will create one, but because it's singleton, that single instance will be used throughout the whole application. And when the second car asks for an engine, again, the same instance of the engine will be injected. And that is why the engines are the same, because they are singleton. And if we change them to prototype, something like this, and tell that we want them to be prototype, you'll see that the engines will differ as well. So we have different engines per different cars. Or if we change this again to singleton, or just remove it because the default one is singleton, you'll see that because a single car will be instantiated, a single engine will be instantiated. So we have a single car with the same address. So the hash code that is inside the object class of Java returns the address inside the memory. And because they are the same, of course, they must have the same engine, and the car constructor should be called only once. So these are the two scopes that are widely used in Spring and also in your application. in your application, when you design your class, most of the time you specify this class's object and its scope as whether it must be singleton or whether we must instantiate a new one every time we need one. But there could be something in between, you know, and you do that manually yourself inside your applications every day. And you instantiate something and cache it somewhere under some map or umbrella and hold that instance and use it in a custom lifespan. And at the end of the lifespan, you just destroy it and you just throw it away. I want to mention here some special, actually, an important difference between the singleton in Spring and singleton in the outside of Spring, which is a design issue. So outside of the Spring, if you want to define a singleton, you have to make the constructor private and provide it and static, for example, a method that could create and instantiate a single one and cache it and return the same one every time. But here in the Spring world, you don't have to do that. Actually, your constructor could be public because it is Spring that has the responsibility of providing instances, and the Spring will provide the same one when it is a singleton. The other difference is that with the outside of Spring in the Java world, and a singleton class actually will be defined per class loader. If you don't know what is class loader in this Java world, it is the object that loads the class's .class files. And in that sense, because we created static inner field, the singleton object will be actually inside the Java will be spanned throughout the whole application by being in a static field and being loaded in a class, in the same class loader. But in the Spring world, a singleton is singleton inside an application context. Again, as you remember, we actually talked about this metaphor of umbrella or lifespan. So the lifespan of the application context, which is this one, the application context. The lifespan of application context is where that a singleton scoped bean definition will have a single instance. But if you create multiple application contexts for whatever reason, each of them will have different singleton, will have their own instances, which will be different. And actually these two paths differ. So if you go with the Java path, you might reach better to the singleton of a class being singleton. Actually make sure that it's singleton. But when you offload it to Spring, you might be careful about multiple application contexts. And also, if you use that inst class outside of Spring, you are providing a way for the user to instantiate it multiple times because you've not made it private. So that is another difference between the Spring and outside of Spring. The other types of scopes that we talked about that are only used inside a Spring Web application, we just want to briefly scratch the surface here and talk about them. So we talked about the singleton and the prototype, but we have request, session, thread, and I think WebSocket scope. And these four will be mostly used in the web applications. And actually, these are custom applications that in that spectrum, their place is somewhere in between. And for example, a request scoped bean definition will have the time span of an HTTP request. So if you don't know what is an HTTP request, because we use the Spring application sometime or most of the times for web applications, when an HTTP request comes from a client, for example, from a web browser or a mobile application, that HTTP request that is actually established and in the backend side, which is a Spring, actually when you ask for an object, an instance from a bean definition that is scoped as request, it will return the same instance inside the request. But outside of that, it will create another one. And if we want to actually create our own scope, we could do that. We could create custom scopes, and the other scopes that I just mentioned and named, the request session and other scopes, are actually some custom scopes that we could do that ourselves. We could create if we need to. Actually, we don't. Most of the time, we don't need this capability. These capabilities are mostly used by framework authors that are creating their own framework or library on top of the Spring, and they need some kind of a scope, custom scope on top of the Spring. So because of that, Spring provides this capability. So if we want to create a scope, we could do that. We could simply do that, and that is by implementing a special interface, which is the scope actually interface. And then each scope, let me just real quick do that. Let's say that we have 1 hour scope. Okay, let's say that we have the scope that if we specify a bean definition scope as 1 hour scope, it will instantiate an instance, and it will set the time, and when it passes and expires more than 1 hour, over the 1 hour, it will create a new one. And in order to do that, we have to implement the scope interface, which is not the annotation, the interface. The interface is in the, I think, yeah, that is the one, I think. Okay, yeah. And these are the methods that we should override. And the most important one is this get. The other ones, I don't want to dig deep here and just teach how to create our own scope. But this one is the most important one, and this is the one that it will ask your object about. And if we want to define it as scope, of course we have to define it as component. And this is the place that you will be called every time that the Spring framework needs an object, which actually, let's say that we change this name to 1 hour. 1 hour. I'm changing the scope to 1 hour, and I've created this instance, this component, which is a bean definition. And I want to use this. I want to tell the Spring that whenever you are going to create an instance from this car bean definition, just ask this 1 hour scope implementation. And in order to do that, we have to register our custom scope. We have to say that di.get bean factory dot register scope. Register scope. And here we are registering our scope, and we could register it with whatever name we want. We could say with 1 hour, the name of the scope, and let's instantiate our scope. Oh, we don't have to actually define it as component, sorry. And we define it, actually we add it to the context from here, but this name. Now it has been added, and when we ask for an instance, it will return the same one. It won't return the same one. Actually, it will ask this method here, and we could write any logic here. We could, for example, cache it inside an inner map or check the time or anything. And I don't want to actually go into details that what is this object factory or the other stuff. I think that you kind of get the idea here that this is a simple storage, a mini storage here. So each scope is an umbrella or a custom time span or a mini storage that every time we ask for an instance by key, this will be the key, the same instance will be returned by that key inside the scope. And that is how we can create the custom scopes, and that is how the annotations are actually, other frameworks are creating their own scopes. One last thing that I want to mention is that this scope annotation, which is inside the Spring, of course, which is from the Spring annotations, and for determining the scopes, that is other meta annotation that we could create our own annotation. So instead of actually this 1 hour, which we could have typos or misspelling because it is a string, we could create this custom meta-annotated annotation and say that 1 hour scoped, for example. And let's change it to annotation interface. And let's give the retention as runtime, and also the target as the target should be the type, of course, and the method, because it should be also, we should be also able to put it on top of a bean method, which is for Java config, and we will be seeing that in a future episode. So that is method. And now we actually annotated it as add a scope, and we give the name here 1 hour. We could actually ask for the name here and put an alias for and pass it to this one, but we just want to hard code it. So we have this 1 hour scope, and instead of this, we could say that it is 1 hour scope, which is more readable, and the actually compile time will come to our help, and it will prevent from typos and all that sort of stuff. Okay, that is pretty much everything about the scope, especially this custom scope that we wrote. I wanted to override and add the logic here, but I don't want to do that now. Maybe we could do it sometime later, because we don't need it actually. You kind of get the idea. It's very simple. And we talked about the meta annotation of the scope, and also that spectrum of the lifespan of a bean definition. So each bean definition has a unique name, and when we ask for a bean, that bean will have the same name, and that name will be the key of this bean. And when we ask for a bean with this key, we will get and receive the same instance under the same scope. And that same scope, if it is Singleton Scope, we will get the same one throughout the whole application. But if it is prototype, each scope will be actually local to a single instance. So we will get a new instance every time we ask for it. And of course, there are some ways in between actually in the spectrum, and we could create our own scope which has a different lifespan.